wondering, looking around when you said the story about the roses, and listening to what I hear currently as a foreigner but living for 9 years in the US, I think there would be many in the room that would love if you would send this ticket in November to your former teacher instead of somebody else potentially to be at your inauguration. But that leaves us up to everybody's personal taste. So let's see. Are we on? Yeah, perfect. Fantastic conference, and actually you will see I agree with many things that Dave said before. And I'm wondering, you know, when you came in here, have you seen the Bulbasaur? Have you seen it? Well, you know, you should have been in a little earlier. When I was in here at 7 o'clock, he was still in here. But if you have not seen him, maybe there's something else missing. Maybe you're not in Pokemon. You're not in Pokemon? Well, then you will never see Mr. Bulbasaur. Well, my son is on Pokemon, and he sees already the Ivysaur, because on level 16, the Bulbasaur becomes the Ivysaur. Level 32 for the specialist here, it will be the Venusaur. But that's actually less the topic. The question is, do we see change coming before it's coming? Do we see, did anybody here believe, we all looked at augmented reality? I mean, this is a decade old, it's something new. But now it's in everybody's pocket. There's a park I can't go anymore because before I could walk there alone, but somehow that seemed to be a park where you get a lot of these equipment for your Pokemon Go, and everybody's there walking around with a phone. So something has changed theoretically. But the key point is, when you haven't seen this, and I haven't seen it, many haven't seen this either. Many haven't seen what really digitalization, how this changes how we act and interact. And if you think about the Fortune 500 companies, and you look at the list, and you look how many are still around, you know, Pierre said it very clear. Digital is the main reason that just about half of the companies of Fortune 500 have disappeared since the year 2000. Half of the company. That's pretty much. Now, of course, some were acquisitions, some split, they fall out of the list. But just half of the Fortune 500 companies. So what do you think will happen in the next 10 years? Give me a feel. Who says the next 10 years, more than 50% will again be off the list? Anybody here in the room? Nobody. Okay. Who says more than 20%? All right, at least some. Well, John Chambers from Cisco, he said at least 40%. So we will see, let's assume he's not completely wrong, we will see this going on. And the question is, and that's what I would like to look together with you into today, is what does it really mean for companies? What should they focus on, and how can they make sure that they are still on the list when we look at the Fortune 500 list in 10 years? And some companies are acting pretty radically. I mean, that GM, and they don't have very deep pockets right now, that they put 500 million on the table to buy participation in Lyft, that's a big step. And when you look at the automotive companies that yesterday only talked about Freude am Fahren and how great it is to drive a BMW, an Audi, a GM, or a Ford, now they all talk about being really mobility companies, a complete change in their view of the world. And this family-owned company, they're Lego. Anybody here in the room ever played with Lego? If you don't have Pokemon Go, some of you had Legos. Well, I remember these blocks of Legos. When I walk in my son's room, it looks very, very different. There's a lot of high-tech there. Lego actually was at least twice at the verge of bankruptcy. They reinvented themselves again and again and again. And today, it's not only the little blocks anymore, which I enjoy with my creativity. They have a completely different offering targeting at the young people of today. So one thing is for sure, we don't know exactly if it's a big data or it's what exactly is going to happen. We know one thing for sure, data will grow, like you described before, but one thing I believe is also for sure is we have to think about the company as a real digital enterprise. And when you think about a company like Maserati, for example, you know, they're not known for me, that would not be the first company I would think of as being the real digital company. They bring out a new car, the Jeeply. It's double as fast to market, and they tripled the volume of this car, and it's in a completely different market segment than it was before. Fascinating how they are addressing in their specific niche, expanding their niche, and significantly changing their customer base. Now, the key question here is, what is it? And if I split the company in three pieces, let me do this way. In the first part, I would call the creation part. In the second part, the realization part, so where you physically make the products. And maybe the last part is the utilization part, where you can get all the data for condition monitoring, how machines, how products are used. And now I really need your participation. I need you to engage here with me. What do you think is the most important part? And we all know they're all important. What I will ask you now is that you decide. Is the first part, the creation, ideation part, the most important one? Is the second, the realization, so where the products are physically done, the most important part? Or is it all the information from the usage of the different product systems that are out there? A car, phone, whatever we use. What is the most important part from the point of view of the company that designs, manufactures, and delivers those products to their customers? So, may I ask you for the first one? Is the ideation part. There where the creativity comes in, and there really how the product is designed. Is this the most important part? At least 1, 2, 3, well, okay, 4, thank you very much. So, anybody thinks the physical realization is the most important one? Okay, 2, 3, 4, great. And the last one is, it really only matters how you use the different products. Okay, well that's a very clear direction in the usage part. Who has not raised his hand? Okay, well he or she probably is of the opinion that you really have to look at it in an integrated fashion. And that's the obvious one. But very often we forget this. You think about the next system to improve our R&D efficiency. Or we look at the manufacturing plant. How can we increase productivity from the annual 5% ideally to 6 or 7% back? Or we look into the big data world and try to get all this great information, hopefully information, not only data, from the field to understand what's happening really out there, how are our customers using our products. But the key element here is the full integration. And I will come back also to Dave's point there, how do we manage this integrated vision and really create insight out of the information, out of the data you get. And our real petitum here is the integrated view and seeing it again and again. So using the information coming in from the utilization phase into the ideation, improving your product, and physically realizing the product. And when you think about this today, this is enormously supported by tools. When I walk through many of our customers in the automotive industry, aerospace industry, here in California, many of the high-tech companies, they started with their silos, but they are now more and more integrating the information flow across the design space into the manufacturing space, into the utilization phase. And I would like to give you a specific example of an automotive customer of us. If you are a designer and you get this requirement in that your rear view mirror on the left side should be 2 millimeters, or should be a little larger. You don't have the exact requirements, a little larger. But if you're the designer and you know in real time, in this moment, that 2 millimeters means it can not only be manufactured in Detroit, but also in Rüsselsheim and in Shanghai. Well, that's a big information to know, because if it's 2.5 millimeters, it takes 6 weeks to change a manufacturing facility in Shanghai to be able to produce this. And this real-time information across the different parts, ideation, realization, utilization, this really makes here the difference for the integrated productivity. So, the question is always, and again, we heard this before, how do you make it real? That the base idea is that everything is becoming digital. We know this from yesterday. I mean, this is obvious. The question is, how do we make it real? And there, let me add this part to it. Today, we all simulate the different processes. We simulate a product. That we do have a simulation for a car, that's standard. But all these simulations today are still in an isolated fashion. And we think about it that you have the opportunity to kind of dial the clock forward. So if I would make this change, let's go back to this rear view mirror. If I would make this change, which kind of implication would this have in my manufacturing facility? Which kind of implication would this have in my delivery chain? Which kind of implications would this have for my customer in the daily use? This is the vision that's really behind it, by taking all these different simulation tools, bringing them together, simulation data, test data, customer usage data, where you really have an integrated view of your physical product with your digital product, the so-called digital twin. And I would like to give you here one example. So for example, at this tractor, one of our customers said, well, I would like to make one of these parts that are important, I would like to make it lighter. And I completely forget about the restrictions I have today in my manufacturing. Actually, I will 3D print the part. Now, why was this important? When we talk about 3D printing, we still very often think about this physical additive manufacturing part. And that's probably answering 5 or 10% of the opportunities that are actually in additive manufacturing. But the real value is in the opportunity to design products, here in this case, to have a product which is designed with influences from nature, so to have 30% almost weight reduction in this one part. Now that's only a test case for this one part. If you drive this through this whole product, you have an opportunity to reduce weight by probably around 20%. And if you're in the automotive industry, especially when you design trucks, well, you know what 20% design change or weight change means in your engine. So the point here is the opportunity with conversion modeling and generative design, like we saw here at this tractor, to really have an integrated opportunity to take maximum advantage of new technologies like additive manufacturing. One of our partners, who knows Local Motors? Anybody knows Local Motors? Fascinating company. So this company has 160 team members. Not a big company, it's just for about 10 years. But they have 50,000 people in their crowdsourcing team. And the idea is, or what they do is, they do competitions. The last competition they did was for Airbus, to design a new drone. And they received 400 entries. 400 entries after 6 weeks that can be manufactured. So they followed the first test. They were able to go through the first test. They produce them, and then they select them. 3 of them were winners. The one that's actually produced, the winner gets a check, and he gets a percentage of the revenue afterwards for this drone. It's produced in microfactories around the world. Jay Rogers, the CEO, has a vision of hundreds of microfactories, and he uses very extensively additive manufacturing. Why is this interesting for us? We have all been discussing for years that at some point in time the typical company structure might dissolve. You see this now with a company like Local Motors. The key participants, in this case, for example, was the last design, which was a self-driving bus. The one that won was an individual from Colombia who currently studies in Italy, who won the competition in the US, and the first bus is driving in Berlin. And he was not an employee of Local Motors. He was a competitor in this competition for the best design for the self-driving bus. And then their additive manufacturing adds another opportunity of higher flexibility, so decentralization of ideas and decentralization of realization in the factory floor. Another company we work with, they use hybrid. So the first, this turbine here is additively manufactured, and then there's a subtractive process to get the surface in this quality they need for their application, and they have a reduction there from 8 weeks to 36 hours. So it's not this 5%, 10%, it's a completely different game that they can now play. And other parts, you know, before, do you remember this little baby there? He was always behind the curtain. You never know exactly who was protecting whom from whom. And now the opportunity with cobots, this integrated working, that's the one part. But the other part is, how can you simulate this process and integrate this information back into your ideation process? So when you design the new product, you not only know what you want to produce, you already know how you want to produce it in your environment. And then, of course, the mechanical, electrical, and automation design. By the way, that was an interesting discussion with university in Germany. And the US is for sure completely different. But in Germany, the professor who is responsible for mechanical, he is a strong belief this is the core. Mechanical design is what really matters. And then you walk across the aisle and you go to the Institute for Electrical, and you definitely hear that this is the most important part because that defines the future. And then you go across the street to the Automation Institute, and they can tell you with all good reasons why they're the best ones. The problem is they don't really work together. But at the end of the day, you don't care. You as a customer or as a producer, you have to integrate all the capacities here. And this is the other part of how do we integrate those into a future complete integrated design. And you see here one example of how we are doing this with our own automation equipment in our own factories. So last but not least, let me jump into the utilization space. And there I want to come back to the big data. Because I fully agree with your point before. There is a school which says the information is all in the data. So just do some great analysis, show a lot of data together, and then you find patterns, and the pattern will tell you the story. And there's a little bit of truth in it. The patterns tell you correlation. Well, we all know, the latest since we went to undergrad, that correlation or causation can be the same, but it doesn't have to be the same. And there's a big challenge in everything we do when we look at big data without a deeper understanding of the models behind it that created those data. And this is where we believe the opportunity is in there for companies to really take the data from the utilization space and throw them back into the ideation. So into your model, how do you design the product, the digital twin of your product, and correlate those, because then you get real information. What does it mean that, for example, and let me give you a very specific one. This gentleman here, an executive from Dell, where Dell uses the information from how you use your computer, and if you have an error message, and you have allowed Dell to get this information, then they go back into their design process, into their supply chain process, and you all know they have a very long supply chain process. They don't only have to know the supplier, but the sub-supplier and the sub-sub-supplier, and they correlate this information and then look at this together with the information they have from their own design and how this relates to your error message. And there, Michael, he told me that they were able to analyze billions of data and put it in context of their information, of their design information, and out of this get to results in hours, which took them weeks before. So a completely different opportunity to hopefully analyze your failure, your PC, and act to it very, very fast. So let me put this together. It's 3 messages that I want you to bring across today. First, it's not about the silo of design or manufacturing or the utilization space. The key element is really how can you get the digital thread of information, of a digital twin, of the physical product system you use, you sell, you produce. How can you get this integrated and together? And there are companies today that do this on a very, very leading edge, which we can all learn from, at least to my view. I shared some of them with you. Second, model-based performance analytics. It's not about just the information in the data. You have to sync it with the model that represents, again, your product, your system. And last but not least, database performance analytics. Yes, to be able to do this, you have to have the sensors out there. You have to get the data. But it's the data alone doesn't tell you the whole story. And with this, thank you very much. And never forget, the barber store was here in the room this morning. He might be here tomorrow if you're early enough. Thank you.